Hello everybody, welcome to another video Python for Linguists related. And this one actually is the second to last video in this introductory series, so you're almost there. And it does introduce a new data type, a new data structure, and that's tuples. So let's jump in right here. Normally I say be ready to code along, but this is really a short video where you can code along with some of the examples. But I didn't even include any particular exercises on tuples because it's really just a setup, kind of a preparation exercise for doing some more work with regexes, with particularly with groups within regular expressions. All right, but before we get ahead of ourselves, let's have a look at what tuples are. Perhaps you remember when we talked when I introduced dictionaries. And we did this, or I did this, with a German sentence translated to English. Der schnelle braune Fuchs springt über den faulen Hund, which in English is a pangram. The quick brown fox jumps over the lazy dog. So a sentence that includes all letters of the alphabet. But that's beside the point. So one way to create this dictionary was to take the one sentence as a word list and then the other sentence as a word list. And in this case, it's fortuitous because the number of words and their position in the sentence actually matches between English and German, so you can really create the dictionary just by zipping these words together, these lists together. And what we did was basically zip the two lists and then wrap a dict function immediately around that, right? So something happened with the zipping, but we didn't even look at what zipping does. We created a dictionary out of the zip list right away. So let's unpack this a little further. If we omit the dict call, we get something like this. Tups, and then we zip two lists. Then if you do 4x in tups and print what that is, you can do this for yourself. And I'll just very quickly do it in the live show. Right, so we zip two lists together and then 4x in tups. We get the following. So we get the thing displayed, and then this object is A. So in regular parentheses, the, comma, der, this object is a class tuple. Then again, in regular parentheses, quick, comma, schnelle is a tuple, etc. So a lot of this looks pretty familiar, right? If it had square brackets, it would be a list, but it has round brackets, round parentheses. So what's going on here with the square and the round parentheses? Basically, we have something that's a lot like a list, but different in a few key ways. So what is a tuple? It's an immutable sequence of objects. And immutable is really the key thing that's different from a list. It can't be changed. It can contain anywhere between 0 and almost indefinitely many elements, and they're immutable. In other ways, in a lot of other ways, they're like lists. And where lists use square brackets and strings use these quote marks to be defined, so Python knows that it's now looking at a string, and a dictionary has these square brackets, these curly brackets. Tuples use just regular parentheses, right? So if you define something, my list is 1, 2, 3, 4 in square brackets, then the same thing goes for my tuple is 1, 2, 3 in round parentheses. The only thing to keep in mind is if you want to initiate a single item tuple, you can't just take a value and wrap parentheses around that, because there's a more basic function to that, right? In mathematical sort of order of evaluation sort of terms. So for it to be parsed as a tuple, it needs the item and then a comma and then the closing parenthesis. That's just a bit of an idiosyncrasy. And if we look at tuples versus lists, you can do a lot of similar things, right? If we look at the first 8 lines to the left and to the right, they're basically identical. So we have, this is the my list and my tuple from up here, right? 1, 2, 3. That's just what's in these. Len my list returns 3, and len my tup also returns 3. My list index 1 returns the item 2. My tuple index 1 returns the item 2. I can add the list 4, 5 to my list, and that simply is going to get the combined list 1, 2, 3, 4, 5. I can add the tuple 4 and 5 to my tuple, and then I get a tuple with the elements 1, 2, 3, 4, 5. I can check membership. Is 3 in my list? That returns true. Is 3 in my tuple? That also returns true. And only then, at the very bottom of the list, we get to the difference that really is important. My list 0 is new. What's happening here? I'm going to the index position 0, so the first item in my list, and I just overwrite it. Instead of 1, the integer 1, it's now the string new, and Python is happy to accept that and will return that. If we try doing that with a tuple, we get a type error. Does not support item assignment. So tuple is fixed here. And there's a couple of contexts where this being fixed allows you to do things with tuples that you can't do with lists. We'll get to that in maybe like 2 slides. In general, what are tuples good for? If you look this up online, I found this nice, very condensed explanation that says basically you should use tuples whenever there's a constant structure. The first position always holds one type of value, the second another, and so forth. And lists should be used for lists of homogeneous values. So just words in a text, that's lists. But if you have something like word, lemma, part of speech, for every item in a text, right? It always has the same structure. Everything in index position 0 is going to be the word. Everything in index position 1 is going to be the lemma. There's a sort of a semantics to the structure of items within the sequence. Then a tuple is a good way to go. If you click on that link or follow that link, there will be, I guess you have to click on the HTML slides to get to the clickable link here. But if you look that up, there's more discussions around this that kind of go into more depth and explain things in more detail. And one of the things I liked from the discussion is you can also think of a tuple kind of like a dictionary where you didn't bother to write the dictionary keys. So you have all the values, and instead of a key, the position in the tuple just somehow, well, you have to know its structure, but if you know its position, you have a sense of what the value represents, right? So you can have a dictionary for each word in the in your text where the keys are word, lemma, part of speech, and the values are the actual word token, that token lemmatized, and then the part of speech tag for that. But you can also have a tuple where you just get the actual values and you just know that items 0, index position 0, 1, and 2 correspond to word, lemma, and part of speech. So that's the way to think about tuples. Mostly, if we think about this in linguistic terms, right, word part of speech would be a great use case, great example where a tuple makes sense. You can also think why a dictionary would not make sense here, for every word to assign a part of speech in a dictionary format, where the word is the key and the part of speech is the value. Word index as well, and that's actually if you use the enumerate function on a word list, that's precisely what you get, the word itself and its corresponding index position. Word 1, word 2, and so on until word n in an n-gram. Again, there it's all words, so similar to a word list, but for the purposes of analyzing this as an n-gram, the word 1 is always the first item in the n-gram. Word 2 is always the second item in the n-gram, etc. Or if we have a linguistic variable or a linguistic construction that we're interested in, you could look at the way construction, for example. That's she elbowed her way across the dance floor. He smoked his way into hospital or whatever. you could sort of extract whatever is interesting linguistically, and while you extract, keep track of the individual variables, like so. The verb, right? Smoke versus elbow. The possessive pronoun, so his or her or its way. Then way can be in there. I mean, it's a categorical thing, so uh, it may be omitted because it's never going to change anyway. And then the preposition, right? Across, into, up, etc. And then you represent all of the interesting elements of each way construction in a condensed format where you have all of them, and if you want to look at the verbs, you just take the first thing in each of these tuples and you have the verb. This is actually sort of what we're going to do with regexes in the next video. We're going to use the power of regexes to to yield different parts of a given regex in tuple format. So this example kind of foreshadows what we'll be doing with regular expressions. And this is what you mostly will find online, what they're useful for. They can be dictionary keys because they're immutable. Only something immutable can be a dictionary key. That doesn't apply to lists. So you can't use a list as a dictionary key, but you can use a tuple. For example, right, word frequencies, you can have the tuple house verb in there, and count all instances of house used as a verb separately from the instances of house used as a noun, for example. There is, there's obviously the alternative of just one string where it's house underscore v or something like that. Personally, I've never come across the case where I absolutely needed tuples as dictionary keys, but there you go. It's a possibility if you should ever want something list-like as a dictionary key, but lists don't work because they don't. They're not allowed as dictionary keys. That's really all I wanted to say about tuples. We'll learn more about how to actually use them with regular expressions in the much longer and more complicated next video. But for now, I'd say that was not too hard. Take it easy, and it'll get more complicated soon enough. Thanks for now. Here are my image credits and also the link to my slides. Thank you very much.